Okay, Andy, here we go, buddy. I'm going to try to do as much of this review as I can and explain it. I don't know if this is going to be exactly what you need, but we'll do our best. And here we go. First off, I share the screen. Let's see what we got here. I just shared this one. Okay. So I'm guessing that you can see this. Actually, get a little bit focused on there. Okay. So here's what we're going to do. I'm going to just go through this, and then each time I'm going to suggest things that you should put on your thing. Now I got to get out of here in about 20 minutes. So no matter how much this goes is what we're going to do. So essentially, when you're looking at the perimeter and area of these figures, what you're looking at is you need the formulas for those areas. So that would be something that you go into your book and you take a look and you try to write those down, like area of a circle, area of a rectangle, area of a triangle, same thing with circumference of a circle. So what I've got here is a square, and I take a quarter of a circle off, right? So a lot of times what I'll do is the shape like this to figure out what's going to happen. And so area part's easy. Area for this one's going to be length times width. So this is 20 times 20, or 20 squared. Minus, now I need to find the area of this circle and divide it by 4. Area of a circle is pi r squared. So it's going to be pi times the radius, which is this half right here is 10. So 10 squared, and then I'm going to divide that by 4. Now, I could plug that into the calculator, and it's totally fine to do that. This will be 400. This will be 100 pi over 4, or 25 pi. I'll subtract them. I'll get a number. Totally fine. And I'll let you do that because I don't want to take up the extra time. If I'm going to do perimeter, I basically need to add all the outsides, right? So we'll have 20 and 20 and 10 and 10. So that's a total of 30. Plus, this is a quarter of the circumference of this circle. Now, the circumference is 2 times pi times the radius. So our radius is 10. So that is going to be 20 pi. That's the whole circle. But if I divide that by 4, 20 divided by 4 is 5. So we will have 30 plus 5 pi centimeters is the perimeter of that shape. I hope that kind of worked in terms of what we're going to be doing there. Here, we've got a rectangle and a half circle. What we have to look at is this distance here, and we need the radius. So that's the diameter is 4. The radius is 2. So the area for this one is going to be the rectangle, which will be 4 times 6, plus half the circle, pi times 2 squared. So this will be 24 plus 2 pi centimeters squared. Now, I don't know if your teacher wants you to change that to 3.14 and get a decimal or not. That'll be up to them. You can just use your calculator and plug that in. For the perimeter of this, we got 2 6s and a 4. So 6 plus 6 is 12. 12 plus 4 is 16. Plus half that circle, right? So this will be half times 2 times pi times the radius, which is 2. Well, half times 2 is 1. So this will be 16 plus 2 pi centimeters. And then for this last one over here, what we are going to be doing is finding the square here. So 12 times 12 is 144. The formula for the area of a triangle is 1/2 the base times the height. So 1/2 times the base is 12 times the height is 5. So that's going to be 30. So the area of this is 174 by adding those two together. And don't forget your meters squared, because that's what we're going to have for the label for that. And then the perimeter itself, we actually got a little bit of work here. So that's 12. We've got 3 sides of 12 here. 12, 12, and 12, that's going to be 36. Plus that 5 there. And then we have to find that diagonal. Now, that's a right triangle. So there's a thing called the Pythagorean theorem that is the length of the sides of a right triangle. A squared plus b squared is equal to c squared, where the c is the hypotenuse, the one that's opposite our right angle, okay? And so these two are the legs or the sides. So 5 squared plus 12 squared is going to equal c squared. And now we do the math. So this will be our c. 5 squared is 25, 12 squared is 144, is equal to c squared. This is 169. is equal to c squared. The way you solve for squareds is by taking the square root of both sides. So c is going to equal 13. So this one right here is 13. So 36 for these sides, 5 for that side, and 13 for the diagonal is what we're going to get. So if I add this together, 36 plus 13 is 49, 50, 51, 52, 53, 54. This will be 54 meters is the perimeter there. Okay, now talking about the missing measurements with the stuff that we have here on triangles. So with this, area of a triangle is 1/2 times base times the height. That's our area. So they've just told us that that answer for the area is 38. They told us that the base is 8. And we still have my half here. So you're basically just solving an equation. My unknown is the height. I'm going to multiply these to simplify it. So that'll be 4h is equal to 38. And if I divide both sides by 4, I'm going to get that h is going to equal, I'll use my calculator here. Sorry about that. I'm sure what I got that, but 38 divided by 4 gives you a happy 9.5. So that is a 9.5 inches. Now for this one, circle, the area of a circle is pi times the radius squared. The circumference of a circle is 2 times pi times the radius. So what they're going to want you to do is to use the circumference that they gave you is 14 pi. So you substitute that in for c, 14 pi equals 2 times pi times the radius. Now we're solving this for the radius. So I'm going to divide both sides of this by 2 pi. Pi cancel, 2 cancels. Pi cancels, so our radius is 14 divided by 2, which is 7. And then I plug that sucker right back into here, so this is 7 feet, to solve for the area. Area is equal to pi times 7 squared. 7 squared is 49. So the area is equal to 49 pi feet squared. All right, and there's that one. Now, midpoint of the segment. Okay, so your midpoint is essentially, you take your 2 x's divided by 2, and then you take your 2 y's divided by 2. So midpoint of the segment PR. So I always draw it. So Q is the midpoint, P, R. So this is -6, 4. This is 2, -1. You're trying to find the number in the middle. So -6 plus 2 divided by 2. And 4 plus -1 divided by 2. That's going to be our Q here. -6 plus 2 is -4. -4 divided by 2 is -2. 4 plus -1 is 3. 3 divided by 2 is either 3/2 or 1.5. So that works for that one. Now, normally what they'll do is they'll do another one of these where they'll give you the 2 here and tell you to find the other one. And that's fine. So let's do that. I'm going to show you another way of doing it. So P is -10, 2. Q is -1, -3. And they want us to find R. Now, here's what I'll do, okay? I know that if this is the halfway point, then I'm going to figure out where this is going to be at. So -10 to -1, I have gone +9 to get there. I have to add 9 to get here. So if I got to do that same thing, -1 plus 9 is going to give me a +8 there. That is absolutely what this one's going to be. You do the same thing for your y values. 2 to -3, you're going to have to subtract 5 to get there. So I'm going to subtract another 5 here. -3 minus 5 will give you a -8. That is a way that you can also do it. So you can either use the formulas, plug them in and solve them, or we can do it this way to be able to figure out where those are at. Next, triangle DOG has these 3 things. Find the side lengths of DOG using the distance formula. Give your answers in simplified radical form. Now that's a lot. We did a little simplified radical, but not a ton. So you're going to have to do the distance. Distance formula is just a version of the Pythagorean theorem where these are the sides. So what you're basically doing, it starts with your distance squared is equal to your length on your x's. So x1 minus x2 squared, so that's how far the x's have gone, plus y1 minus y2 squared. So this is like a squared, b squared, and c squared. And so ultimately the way they're going to give you the distance formula is with the square root all over that, x1 minus x2 squared plus y1 minus y2 squared. This is going to take a second. So I'm going to do this. I don't know that I'm going to be able to do all three because of time. So what I'll do, I'll plug in a couple of them to sort of show you what to do. Let's do DO to start. So for DO, for plugging it into this, big square root, x and x, we subtract those. So 0 minus 2 squared, and then y and y, -1 minus 5 squared. I always write it all out and try not to do it in my head because it shows me where things are from. Now I can do this part in my head. I know that that's -2 squared. I know that that's -6 squared. -2 squared becomes a +4. -6 squared becomes a +36. So when I'm done with that, I will put the square root of 40. Now, simplification, what you're looking for is all of your perfect squares in that. That is the same as the square root of 4 times the square root of 10. And I know square root of 4 is just going to be a 2. So 2 root 10 is the simplified radical form. If I'm remembering correctly, if you get to use your blue calculators, you can just plug this in and it'll give you the answer. But that's how you simplify it, is you look for what perfect squares go into that. Let me do OG, and then you can do the DG yourself later. OG, by the way, this formula, you're going to want that written down for sure. OG is going to give you same idea, big square root, subtract the x's. So 2 minus -4 squared, and then subtract the y's. 5 minus 3 squared. 2 minus -4 is going to be a +6 squared. 5 minus 3 is going to be a 2 squared. Holy crap, it's the same as this. So this will be 36 plus 4, or square root of 40. And we know from what we just did here that that's 2 root 10. And then you can do the same thing for the other. The idea is just trying to break it down, plug the things in. A lot of times you'll get the same values depending on where they're going to be at. Okay. So that being said, that is first page. Let's look at the second page and see what we can do. Why don't I start with the coordinates of the image and move the stuff? I'm going to tell you what I do when I do this. First thing that I'm going to do is start off with writing what those are. Okay. So we want the coordinates, and they're not saying for you to draw them or for you to draw all the things, but it helps me. So first, let's write the coordinate for F. That is -4, 5. Coordinate for E is -4, 3, and the coordinate for G is 1, 1. So what I'm going to do is actually take us through these. The reflection over the y-axis, that means everything goes over this way. So this one right here becomes G prime. This one has 4 in this direction, so it's going to be 4 in this direction. So that'll be E prime. And this one goes 4 in that direction, so it's 4 in that direction. That is F prime. The reason why you want to draw them is because it's helpful to see that you have done each of these pieces. Okay, so here, that means that our 3 things will be F prime is 4, 5. E prime is 4, 3. And G prime is -1, 1. Essentially what you do when you reflect over the y-axis, you flip the x's. In your book, there will be a list of what those transformations are. So it'll be like, if it's over the y-axis, it will tell you that xy becomes -xy. And it's helpful for you to kind of go to be able to do some of this stuff. Now, the next one then is a 90-degree rotation about the origin. Now, let me show you what I do when I do this. So we've got this one here, and I know what all of these points are. If I'm going 90 degrees about the origin, I'm going to change colors so it's not going to be something that's going to be confusing. I actually rotate the entire thing 90 degrees this way and graph the points again. Okay, so like I know that my point that we wrote down here for G prime is -1, 1. So I'm going to go -1, 1 and do this right here, and this will be my G double prime. And then the E prime was 4, 3. So from here, graphing like it's a regular thing, I go over 4 this way, up 3 here. Essentially what you're doing is, since I've turned the whole thing sideways like this, I'm just graphing it as though I've turned the sheet this way. F is 4, 5. Excuse me, F prime is 4, 5. So I go over 4. I go up 5. That's going to put me right here. This is going to be F double prime. And so this triangle right there is the same one, but I've rotated it 90 degrees. And you can see I literally rotated this 90 degrees and graphed the same points. Now, to see what the new values are, you turn it back, and you take whatever values I have here, and those are my values. So here I've got G double prime, so I'm going to put that right here. And where it actually ended up was -1, 1. So we'll go -1, excuse me, -1, -1. Sorry about that. And then if I look where I'm at here, I've gone -3, +4. That is E double prime. And then the F double prime is -5, +4. That is F double prime. Now, a 90-degree rotation about the origin, the rule will tell you that XY becomes -YX. It's totally fine that it tells you this. You're essentially flipping them and making the first one the opposite. Or excuse me, making the second one the opposite. No, making the first one the opposite. I was right. So you flip these, bring where the Y's were to the front, and then make those the opposite of whatever they are, and then put these just second. And that's fine. I prefer doing it by hand because I think it shows you what it is looking at. Okay, and I'm going to keep going up from the bottom here and checking my time. I think I can get this, but we're going to see. Okay, we are naming the angle relationships. Now, there's absolutely a page with these, so it'll be something you can look at. If I look here, PEX is this one, MEY is this one. Those are across two intersecting lines like this. So that is PEX and MEY. Those are called vertical angles. That's what we call that. MEY and TEM are right here next to each other, and they make a right angle. Two angles that make a right angle are called complementary. XEY, and by the way, if you're not used to the naming of that, that's just the order of what you put them. So XEY is this guy here, PEX is this guy here. So this and this go together to make 180 degrees, so that would be supplementary. Or they're also called a linear pair because they make a line. Complementary, you could also call them complements, which is fine. And then you have TEP, which is this one here, and TEM. Now, those don't add up to anything particular, but they share this side in the middle. So they're right next to each other. So those are called adjacent angles because they are right next to each other. Okay, now, does that make sense? Good. Here we go. I asked you a question you can't answer because I'm videoing this, but that's fine. All right, going back to this, when we say complementary, this means they add to 90 degrees. So this means that the measure of angle G plus the measure of angle M is equal to 90 degrees. G is 20 more than 3 times the measure of M. Good God. Okay, so when you see the word is, that's your equal sign, right? So the measure of angle G is 20 degrees more. So 20 plus 3 times the measure of angle M. 3 times measure of angle M, and they want you to find the measure of angle G. All right. Oh man, it's a full-out substitution. We did do this, but it's been a while. So I look at where measure of angle G is. It's right there. That is, we have 2 equations. This one right here, measure of angle G, I'm going to replace that with this so that it is its own entity and everything is in terms of the measure of angle M. So I'm going to plug in 20 plus 3 measure of angle M into this one. So 20 plus 3 times the measure of angle M plus the measure of angle M is equal to 90. Now I have an equation. The variable is M. So I've got 3 and 1. That's 4M. Notice how I changed it so it's not the measure of angle anymore. Plus 20 is equal to 90. Of course, they're going to give you one of these. That's a decimal. Okay, so now if I'm going to solve this, I'm going to subtract 20 from both sides. And I'm going to get that 4M is equal to 70. And then I'm going to divide both sides by 4 and get that M is equal to, or the measure of angle M is equal to 70 over 4, which is half of 35, which is 17.5 degrees. Then, because they're complementary, if that's 17.5 degrees and it has to add up to 90, excuse me, if the measure of angle M is 17.5 and the measure of angle G has to add up to 90, then what I'm going to do is say 90 minus 17.5 is going to be the measure of angle G, which is going to be 72.5. Because if I add the two of those together, it will equal 90. So that's a substitution problem. It's a system of equations because there's more than one thing. And then for the last one, we're finding the measure of all the angles below. What you're looking for are right angles, and you're also looking for linear pairs. Here's what I'm going to do. Ready? I'll start with this one in the middle because it's nice. Vertical angles across from each other are congruent. Okay, so this is 112, then this is 112. Now that says that and that are congruent to each other. So that's 112. This one also has to be 112, which means across from that would also be 112. So you see what I'm doing is I'm just filling in the gaps. These are 112s. Now, both of these are next door to another angle that make this equal 180 because that is a line. So 112 plus what is equal to 180? Well, in this case, it is going to be, let me make sure that I'm doing it right, 68 degrees, because 68 plus 112 is going to equal 180, which means that this is also 68 degrees. And that's what I have for both of those. So that's how you go about kind of filling them in. You look for the vertical pairs, or excuse me, vertical angles that are congruent, and you look for things that are marked congruent to figure them out. It's easier to do one like this because this whole thing is 180 degrees. So basically what I'm doing is saying 15 plus 38 plus whatever A is equal to 180, and then I solve. So 15 plus 38 is going to be 53, which means that the measure of angle A, if I take 53 off of both sides, the measure of angle A is going to equal, gosh, what's that going to be? That'll be a 7. That's going to be 127 degrees. Yay, that's the measure of angle A. Now, this last one and the last problem that we go through, it is a bit daunting, but I think that's probably okay. You're just going to try to work your way through it a little bit. So here's what I'm going to do. This is 70, this guy right there. That makes a straight line, which means that E here is going to be, well, it's 180. So this will be 110 degrees because 70 plus 110 is 180. And D is directly across from that. So if that's 70, this one also has to be 70. All right, cool. Then what you're going to have to do is kind of work your way around a little bit. So what I know is that these two angles here make that right angle. So 70 plus 20 is going to equal a right angle. And then if I look here, that means that this is also a right angle. So A is a part of that. So A is 20. This has to go to 90. So that one also has to be 70. And then what I'll also notice is that this sucker is a straight line, which means that this is 90, this is 90. So this one right here has to also be 20 to be able to make it so that this makes it 90 degrees. And you could also look to say, well, this whole thing's 180, so we got to add up and take off 20, 70, 70. Like all of that's going to be in there and it's fine. But this is the way that we kind of go through. You're basically looking for what makes 90, what makes 180, what's right next to each other, what is across from each other like these to figure out if they're vertical angles. And then you just sub them in. And I went 3 minutes longer than I was expecting to, but that was a pretty decent coverage of everything that you're going to need. So I hope that that is all you will need with all of this. And I'm going to stop recording.